Today's topic, we'll start with logistic regression. To understand logistic regression, we need to understand a mathematical function whose name is sigmoid. So, sigmoid is represented like is equal to 1 upon 1 plus e raised to minus x. This is a mathematical function along with the formula. This sigmoid function is most probably used for binary classification. So binary classification means what? The classes are there either 1 or 0, true or false. Two classes are there. Whenever you want to classify any data set in two classes, 1 or 0, true or false, binary classification is used. Remember that here we are discussing about logistic regression. Here the term regression is there, but logistic regression algorithm used only for classification. Regression, which we have seen earlier, which is used for prediction of continuous numeric values. But logistic regression, which we are looking towards, is only used for classification purpose, and the classification is of a type binary classification. And what basis it works? It works on the basis of sigmoid function. So what is the formula for sigmoid function? Sigmoid x is equal to 1 upon 1 plus e raised to minus x. See, depending upon these values, this function work differently. Suppose I take value of x is equal to 0, then this function will be like 1 upon 1 plus e raised to minus 0. For value of x is equal to 0, we can write it like 1 upon 1 plus 1 upon e raised to 0, which is nothing but 1 by 2, which is equal to 0.5. So if x is equal to 0, value of sigmoid function is 0.5. Value of e, can anyone know what is the value of e? Which is a 2.71. So if x is equal to 1, now if we take, then it is 1 upon 1 plus 1 upon e raised to 1, which is equal to 0.73. If we take x is equal to minus 1, then it is 1 upon 1 plus 2.71, because the value of e, which is 0.26. Likewise, these values we can calculate. These values of sigmoid function will be range from 0 to maximum 1, or we can say the graph will be look like this for the sigmoid function. Which will between 0 to 1, here minus infinity and here plus infinity. If you apply the sigmoid function with any value of x, you can take value of x anything. Always sigmoid function will give the range, it will be in between range like this. It will go up to the 0.5, and from 0.5 it will go like this. So 0.5. Where we got x is equal to, when we have 0, we got 0.5. So this is a sigmoid function. We will see how to use this in logistic regression. So you can remember that sigmoid of 0 is equal to 0.5. Sigmoid of plus infinity is equal to 1. You can see here. It will not touch 1, but it continuously goes slightly near to the 1. And sigmoid of minus infinity is equal to 0. It is not going to touch 0, but it goes somewhat near to the 0 likewise. So whatever the values we'll get for the sigmoid function are always between 0 to 1. This is what we have to understand. So suppose I created one machine where I give some values to it, some positive values and some negative values. And if positive value is given, I will get the value near to 1. I cannot say always 1. It is a near to 1. It is not touching to the 1. It is a near to 1. Here it is near to 1. And here it is near to 0. So if negative is given, it is near to 0. So this is a sigmoid function. This is what we have to understand. By using this concept of sigmoid function, we have to understand the algorithm called as logistic regression, which is used for binary classification purpose. So this is what we have to understand. Now let us see, suppose I have points like this. Can I easily differentiate between them? Can you able to draw a line which can separate these 2 points? In this case, we can have a line like this, which may classify the given data set into the two. We can say above the points are classified under one category and the below points are classified under zero category. Can we do like this? If we have one equation, line of equation, which goes between the 2 points, we can classify the given data set. So can you tell me what is the equation of line for this? What is the formula of equation line? Y is equal to mx plus c. So in logistic regression, if we have this line of equation which clearly classify the two objects, we may say they are binary classified. So this line is called as decision boundary. The term decision boundary, you are again going to listen in the SVM, logistic regression and linear regression. First one, in logistic regression, the line we draw is called as decision line or decision boundary. And in linear regression, are you able to recall in linear regression what we are doing? We are identifying the best fit line between the points which are able to predict something. But here we are not doing prediction. Here we are doing the classification between 2 points. So it is called as decision boundary or decision line. In logistic regression, we have a line which is the best fit line for the points which we are going to use for the prediction purpose. Second difference between logistic regression and linear regression is that here we find best fit line or best fit decision boundary, and here also we find best fit line for all given data points. Third, what we can identify, in both the cases we are using gradient descent. Can you tell me what is the purpose of gradient descent? Gradient descent is an algorithm which allows you to identify the best fit line. So in both the algorithms, either you are doing the regression or classification, in both the algorithms, gradient descent work for identifying the best fit line. This is a binary classifier because it identifies two different classes in a given data set. And here, linear regression is used for predict continuous numeric values. And the last difference here, we have a cost function here also and here also. It's a summation of yp minus ya bracket square. Here also we identify the cost, or here rather than calling a cost, it is called as loss function. Here the term they are using called as a loss function, and which is given by the loss function is cost is equal to minus ya log yp minus in bracket 1 minus ya log in bracket 1 minus yp. Actual and yp is y predict. So we are going to see this term when we are going to. I have drawn one diagram where you can see this x are there below the line, to whom I am calling they are under class 1. So suppose these are the class 0 items and these are the class 1 items. So can I say it is a problem of binary classification? 0 and 1. So here I have to identify this point which I am making a red. Suppose this point is there, which is a 2, 2. I have to identify this 2, 2 is coming under which class? It is under class 0 or class 1. As a human being, by looking at the diagram itself, I can see that the 2.2, 2 can come under the class 1. See here, class 1 is there, no? And this is a class 0. But how I mathematically prove that, or how my model I going to train so that I come to know the point 2, 2 come under the class 1. Can you tell me what I need to do? I need to identify line of equation or equation of a line. So how to identify equation of a line? Y is equal to mx plus c. So can you tell me how to identify the equation of line for this? There is a formula x minus x1 divided by x1 minus x2 is equal to y minus y1 divided by y1 minus y2. It will give you the, if I put the values in this, what I'm going to get? X minus 0 divided by 0 minus 3 is equal to y minus 3 divided by 3 minus 0. So which is nothing but x divided by minus 3 is equal to y minus 3 divided by 3. So I am doing 3x is equal to minus 3y plus 9. It is correct. So it is nothing but x is equal to minus y plus 3. Can I say like x plus y is equal to 3? So this is nothing but the line of equation which is passing from 3 comma 3. We understand? We identified the line which separate the 2 points by using equation of line. Are you agree? This is a line of equation for this line. So if we put this into the sigmoid function to identify the values of y predict. Y predict means what? We want to identify where that point 2 comma 2 is coming. So see, yp is equal to sigmoid of f of x. So it's a binary classification. Output will be either 0 or 1. So yp is equal to sigmoid of x0 plus x1 minus 3, which is nothing but sigmoid of आपल्याला कुठला पॉइंट आहे 2, 2 plus 2 minus 3. So sigmoid of 4 minus 3 is equal to sigmoid of 1. Open your Google in the mobile and identify what is the value of sigmoid for 1, or you put into formula and tell me what is the value of sigmoid for 1. It is a 0.73. So can I say it is approximately 1? Can I say it is approximately 1? So what I come to know, my model is predicting the point 2.2 should be come under the class 1. Because what we have seen, sigmoid function will never give you correct 0 or correct 1. It is always near to 0 and near to 1. 0.73 is near to 1, no? Or is it near to 0? Near to 1. So sigmoid of 1 is 0.73, which is near to 1. So yp is predicted in class 1. Are you getting? The same way logistic regression works. This is a concept of logistic regression. Okay, cost function in logistic regression we are speaking about. The cost function in linear regression, how we can see? It is a summation of yp minus ya bracket square. But in logistic regression, either you call it a cost function or someone can call it as a loss function also. And the value of loss function or the formula for the loss function is cost is equal to minus ya log yp minus 1 minus ya log 1 minus yp. In linear regression, we have data points like this. Likewise, we have data points. And we predict some line which is the best fit line. So I may call this line is an actual line YA. And the line which is expected over here is called as an Y predict. So the difference between actual line and predicted line is called as an error in linear regression. In logistic regression, what happened? We have to have a decision boundary which classify the points correctly. But sometimes the classification will be look like this. Here you can see 0 is going here and the cross is coming over here. So we can call it as a misclassification. And this misclassification will lead towards the cost function or the loss function that we have to see. We will see some scenario. Let us see scenario number 1, where we have this particular line and all the points of 0 class are here and all the points of 1 class are here. So can you tell me what is the cost of this? Can I say 0? Cost is 0. So what is the cost of C1? Can I say it is non-zero? Tell me about this. What is the cost of this? Can I say it is non-zero and it is a greater than C1? Are you agree with this? Cost of C2 is non-zero, but cost of C2 is greater than C1. Y actual, Y predict, and the cost. Likewise, table we can if draw. So if Y actually is 0, Y predicted is also 0, then can I say cost is also 0? If Y actually is 1, predicted also 1, can I say cost is 0? Actually it is 1, predicted also 1, can I say cost is 0? Actually it is 0, predicted also 0, can I say cost 0? Actually it is 0, predicted as a 1, can I say it has some cost C1? Actually it is 1, predicted as a 0, can I say it has some cost C2? So these are the wrong classification. Means we have to identify the cost for this. A loss function we have to calculate for this. And these are the correct classification. So if when you want to identify the cost or loss function, you have to apply a formula which is nothing but cost function is equal to minus ya log yp minus in bracket 1 minus ya log 1 minus yp. So by using this particular formula, you can calculate the loss function for this. Let us say an example in a first scenario. Suppose you have yp as a 0, y actual is also 0. What is the cost we have to identify? So how to identify cost? Cost is equal to, can you tell me formula? Minus ya log yp minus in bracket 1 minus ya log 1 minus yp. So here ya is 0, yp is 0. Put the values in this formula and tell me what is the value. You have to calculate log for this. And here remember the log 2 is there. So 0 minus 1 into log 1 minus 0, or it is approximately 0 as I told. It is not exact 0, not exact 1, approximately 0, which is minus log approximately 1. Log 1 is approximately 0. So can I say the cost is 0? Can I write here 0? Do you understand the table and what we are doing right now? In table also we have y predict 0, y actual 0 and cost is 0. Mathematically also by applying the formula we are getting the same thing. So we are nothing but we are trying to prove this particular table where y actually 0, yp is 0 and cost is 0. Actually we calculated the cost here, which is approximately 0. Let us see another case where y actual is 1, y predicted is 0, identify the cost. You apply the formula now and tell me what is the cost. You can wait for 2 minutes and tell me what is the value. You are getting positive big number. So cost is not 0. It is a non-zero. Are you able to understand? Here yp is 0, y actual was 1 and cost is non-zero. It is some positive big number. Let us see another case and try to understand in more clear way. Suppose ya is 0 or ya is 1, yp is 1. What is the cost? Identify, put the values in the formula. Ya is 1, yp is 1. What is the cost? So cost is equal to 0. So not only we have seen what is meant by logistic regression, we try to understand the logistic regression from mathematical perspective. We identify the cost function or loss function, how to identify, and we proved it that this particular formula will lead towards the correct loss function. So this is an end of logistic regression. Now we are moving towards the another topic whose name is decision tree.